Okay, area using cross products. So, area of a parallelogram, we talked about how we can find the area of a parallelogram by finding the magnitude of the cross products of two vectors. Okay, remember this is one of the formulas we used at the beginning, and this formula is also known as the magnitude of A multiplied by the magnitude of B sine theta. Okay. Okay, in this question though, do we have an angle for the parallelogram? I don't have an angle for the parallelogram. So what I can do instead is first find the cross products of A cross B. And then once I have the values, remember we'll end up with 3 components or 3 points. Once we use those points, then find the magnitude of that. And the magnitude of that would be using our 3 points we found, A, B, C. Well, A squared plus B squared plus C squared rooted will give us the magnitude of that. Okay. So if we are fortunate enough to be able to figure out the magnitudes and have an angle in between the two vectors we're using, we can easily plug it into the first formula to find area of a parallelogram. But if we're not that fortunate, we have to go about it the long way, finding the cross product of A and B, and then finding the magnitude of that cross product. So let's go back to our cross product again. In this case, it is P, negative 1, 5, 6, and vector Q, which is 2, 3, negative 1. Okay, cross product, PQ. Okay, cross product of PQ is A2, which is 5, times B3, which is negative 1, and then minus A3, which is 6, times B2, which is 3. That would be our first term. We need to make room here. Our second term is A3, which is 6, times B1, which is 2. Subtract A1, which is negative 1, times B3, which is negative 1. Okay. That would be our second term. And finally, our third term is A1, which is negative 1, times B2, which is 3. Subtract B2, which is 5, times B1, which is 2. If you notice, I underlined every single point twice. All of the points are used twice when using cross product. Okay. Then we saw from there negative 5 minus 18, 12 plus 1. Well, wait, sorry, minus 1. And negative 3 minus 10. We get negative 23, 11, negative 13. Is that right? Yeah. Okay. Now we have the cross products. Well, we need to now find the magnitude of this. So to find the magnitude of P cross Q, we plug it into our formula. Negative 23 squared plus 11 squared plus negative 13 squared. I don't know 23 squared. Anyone? Oh, it's in the book. 529, 121, 139, is it? Oh, 169, sorry. And then finally, we would end up with root 819. So, area of a parallelogram using the cross products could be done this way. Again, if we had our angle, it would have been a little easier to solve.